Okay, students. So today we are going to attempt AS Physics, Paper 2, February March 2025, Variant 2. So, yeah, today we are going to attempt AS Physics, February March 2025, Paper 2, Variant 2, 1 hour 15 minutes का paper. Let's start with it. So, let's scroll downwards. Yeah. What is meant by the accuracy of a measured value? What do we mean by accuracy of a measured value? एक measured value की accuracy का मतलब क्या होता है? This basically means how. Let me zoom in a bit. This basically, I think it was better if I do it like this. 1 second. हाँ, accuracy का मतलब क्या होता है? Accuracy का मतलब is how close the measured values are to the true value. How close the measured values are to the true value basically is accuracy. Accuracy का मतलब क्या होता है? How close the measured values are to the true value is basically accuracy. Okay, two solid cubes A and B are measured to determine the density of their materials. Table 1.1 shows the measurement for cube A. अच्छा जी ये measurements है for cube A. You have to calculate the density of material of cube A. How will you calculate the density of cube A? Can you realize this is a cube? Okay, density is equals to mass over volume. For a cube, how do you calculate the volume? Do you remember that a cube has all three sides equal? क्यूब की तीनों साइड्स इक्वल होती है एल एल एंड एल. So the volume of cube is equal to what? L cube. Okay, let me write it neatly here. Volume of a cube is equal to L cube. You have to calculate the density in the units of what? kg meter minus 3. Can you realize your mass is given in grams? आपका mass grams में given है. Convert it into kgs. 31.3 divided by 1000. Okay. Also, your length is given in centimeters. You have to give the density in meters. What will you do? Convert it into meters. 1.53. 10 raised to the power of minus 2 into cube. Whenever you see this prefix of centi, you will multiply it by 10 raised to the power of minus 2. Take a cube. Your answer comes out to be 8.7 into 10 raised to the power of 3. What will be your units? kg m minus 3. Simple. Next step, you have to calculate the percentage uncertainty in the density of the material of cube A. Density has the formula of this. Density is equals to mass over L cube. How will you calculate the percentage uncertainty in density? बेटा percentage uncertainty in density किस तरह निकालोगे? How will you calculate the percentage uncertainty in density? The percentage uncertainty in density is equal to the percentage uncertainty of mass plus 3 times the percentage uncertainty of length. How will you calculate the percentage uncertainty of mass? Very, very easy. Are you given the absolute uncertainty 0.5 divided by 31.3 into 100 plus 3 into how will you calculate the percentage uncertainty of length? 0.01 divided by 1.53. 0.01 divided by 1.53. Can you calculate this answer? Let's calculate it. 0.5 divided by 31.3 into 100 plus 3 into 0.01 divided by 1.53. Also, you will multiply this as well by 100. Multiplied by 100. Let's see. multiplied by 100. The answer comes out to be 3.55%. If you round this off till one significant figure, this becomes 4 point, or you can say just 4%. This is your answer till one significant figure. Always remember that you can write your percentage uncertainty till one significant figure or two significant figure. However, your absolute uncertainty will always be written till one significant figure. हमेशा क्या याद रखना है? एब्सोल्यूट अनसर्टेनिटी का वन सिग्निफिकेंट फिगर होगा, परसेंटेज अनसर्टेनिटी का वन भी हो सकता है, टू भी हो सकता है, डिपेंड्स टोटली ऑन यू. The density of the material of cube B is determined to be this. Okay, so this is the density of the material of cube B. State and explain whether cube A and cube B could be made from the same material. Okay, for this, I want you to pay undivided attention. What is the density of cube A? Okay, so let's write it here. Density of cube A is 8.7 into 10 raised to the power of 3 plus minus 4%. Okay. Can I form a range for the density of A? Can I form a range for the density of A? Yeah, surely. Can I calculate the lower bound? Yes. 8.7 into 10 raised to the power of 3 minus 4% of this original density. 4 over 100 multiplied by 8.7 into 10 raised to the power of 3. This is the lower bound. What will be the higher bound of density A? What will be the higher bound of density A? Very easy. 8.7 into 10 raised to the power of 3 plus 4% of this value. 4 over 100 into 8.7 into 10 raised to the power of 3. Let's calculate this answer. Let's calculate the lower bounds and upper bounds and form a range of density of A. Oh, what am I doing here? So can you form a range of the densities of A? Yeah. How did I form the range of densities of A? I took plus 4% to find the upper bound, minus 4% to find the lower bound. Let's calculate the range of densities of A. 8.7 into 10 raised to the power of 3 minus 0.04 into 8.7 into 10 raised to the power of 3. This comes out to be 8350. What will be the upper bound? The upper bound will be 1 second. This will be your upper bound 9050. Okay. So this is your range of density of A. Okay. Now can you do the same thing? Can you do the same thing for the densities of B? Yeah, sir, we can do that. How will we do that? 1 second. Yeah, let's do it here. Let's try to do it here. Let's try to fit it in here. The density of B is 9.2 into 10 raised to the power of 3. And there is a 6% uncertainty. How will you calculate the lower bound? 9.2 into 10 raised to the power of 3 minus 6% of the original density 9.2 into 10 raised to the power of 3. This is your lower bound of density of B. How will you calculate the upper bound? How will you calculate the upper bound? 9.2 into 10 raised to the power of 3 plus 6 over 100 into 9.2 into 10 raised to the power of 3. Let's calculate the range of densities of B as well. बेटा B की डेंसिटी की रेंजेस भी निकाल लेते हैं, इसमें क्या बड़ी बात है. This comes out to be 8650 and this comes out to be 9750. अच्छा जी. Now now we have to examine things very very closely. ठीक है, ये तो हमने सारी वर्किंग कर दी. You can do this on a rough sheet of paper, on a blank sheet of paper. How will you write the answer? How will you write the answer? First of all, let's do one thing. Let's remove all of this working. Except the ranges, I am removing everything from here. रेंजेस के अलावा मैं हर चीज यहां से रिमूव कर रहा हूं. हाँ, परफेक्ट. सो the range of densities of B is this, and the range of densities of A is this. 1 second, let me. Yeah, ये दोनों क्यूब्स की डेंसिटी की रेंजेस आ गई. These are the ranges of the cubes of both density. Can you see they are overlapping? Like if I draw a number line here, let's say I draw a number line here. This is 8,000, 8,500, 9,000, and let's say this is 9,500. And let's extend it forward as well. Let's say this is 10,000. Can you create a line for density A and density B की range? Yeah, density A की range क्या होगी? 8,300, that is somewhere here से लेकर 9,050. This is your range of densities of A. Can you mark the range of densities of B? Yeah, from 8,650 till 9,750. Somewhat like this. I have just marked the ranges of density of A and B on a number line. Can you realize one very interesting factor? These densities are overlapping. यहाँ पे क्या हो रहा है? Overlap कर रही है. Some values of density of A and B are similar. Hence, cube A and B could be made of the same material. Now, enough of the theory, enough of explaining. Let's write down the answer. Let's keep it here. You will say, the range of densities of A and B overlap. Yeah, you can say. Oh, this was a unique question. You can say the range of densities of cube A and B of cube A and B overlap. Hence, they could be made of the same material. Hence, they could be made of the same material. Simple. Let's further move ahead. State the principle of moments. What will you state? For an object, for an object to be in equilibrium, to be in equilibrium, the sum of anticlockwise moments, the sum of anticlockwise movements, anticlockwise movements about a point or about a pivot will be equal to the sum of clockwise movements about the same pivot. Clockwise movements about the same pivot. Easy peasy, lemon squeezy, nothing complicated here. Let's further move ahead. A solid plastic cylinder floats in water. Okay, there is a solid plastic cylinder that floats in water. It is used to support one end of a horizontal beam AB as shown in figure 2.1. Okay, the cylinder is used to support a beam AB. Okay, no problem in that. This uniform beam has a weight of 1700 Newton. Okay. A beam has length 6 meters, weight 1700 Newton. The beam is attached to solid ground with a hinge at A. Okay. The cylinder is floating vertically in the water. Okay. The top of the cylinder is attached at its center to the beam at a horizontal distance of 5 meters from end A. Okay. So this cylinder is attached 5 meters from end A. Okay, no problem there. The cylinder applies a vertical force of 1300 Newton to the beam. Okay. So there is a vertical force of 1300 Newton like this. Okay. Uh, the beam AB is in equilibrium. Okay, what does this mean? The beam AB is in equilibrium. That means the sum of clockwise moments is equal to the sum of anti-clockwise moments. Secondly, the weight of the person is 660 newtons. Person का weight क्या है? 660 newton. It will be acting downward like this. 660 newton. Simple. Okay. What else do we have? Okay. By taking moments about NA, determine the distance x from A to B. Okay, we have to determine this somehow. Okay, very easy, not that difficult. If you further realize, the uniform beam has a weight of 1700 Newton. What does uniform ka word means? I have told this a multiple of time. यूनिफॉर्म का मतलब क्या होता है? हाँ जी, यूनिफॉर्म का मतलब क्या होता है? वेट एक्ट्स इन द मिडल. वेट कहाँ पे एक्ट करता है? इन द मिडल. दिस इज व्हाट वी मीन बाय यूनिफॉर्म. ओके, अगर वेट बच्चे मिडल में एक्ट कर रहा है, if the weight of the beam is acting in the middle, let's say like this, 1700 newton, the total length of the beam is 6 meter. If the weight is acting in the middle, the distance from hinge A will be 3 meters. बेटा यूनिफॉर्म का मतलब क्या होता है? यूनिफॉर्म का सिंपल सादा मतलब क्या होता है? दैट योर वेट विल बी एक्टिंग इन द मिडल ऑफ द बीम. If the weight is acting in the middle of the beam is of 6 meters, the middle of the beam becomes 3 meters. Okay. By taking moments about end A, calculate the distance x from A to B. First of all, we will say that the sum of anti-clockwise moments is equal to the sum of clockwise moments. Sum of anti-clockwise moments is equal to sum of clockwise moments. Okay. Now, realize one more thing. ये जो 1300 न्यूटन की फोर्स है, दिस इज कॉजिंग एन एंटी क्लॉकवाइज मोमेंट. व्हाट इज द डिस्टेंस फ्रॉम द पिवट ए? 5 meters. What will the anti-clockwise moment become? 1300 into 5. Now let's come on to the clockwise moment. बेटा clockwise movement निकालने के लिए you have to understand there are two forces. This 660 Newton is also creating a clockwise moment. This 1700 Newton is also creating a clockwise moment. Now, what will I do? First of all, let's calculate the clockwise movement due to this 660 Newton ki force. 660 into x is your clockwise movement. Then, due to this 1700 Newton ki force, 1700 into 3 is another clockwise movement. दोनों को add up कर देंगे. Let's write it here. 660 x plus 1700 into 3. X की वैल्यू क्या आ जाएगी? Let's calculate that. 1300 into 5 minus 1700 into 3 divided by 660. X की value comes out to be 2.1 meter. Easy peasy, lemon squeezy, nothing complicated here. Let's further move ahead. The bottom of the cylinder is submerged into water to a depth of y as shown in figure 2.2. Okay. The beam is attached to the cylinder but not shown. Okay, so the beam is still attached but it is not shown. The force from beam that we have is 1300 Newton. The cylinder has a mass of 11 kg. Okay, so if you have a mass of 11 kg, there might be a force of weight acting downward that is equal to mg. 11 into 9.81. This weight comes out to be what? 11 into 9.81. This comes out to be 108 Newton. Perfect. The beam exerts a vertical force of, okay, the cylinder is in equilibrium. Now, what do I mean by equilibrium? By equilibrium, I mean the force on the downside will be equal to the force on the top side or on the upside. Can you realize there are two forces acting downward, 1300 and the weight? Okay, 1300 plus the weight, 108. What will be the upward force? Can you realize that the cylinder is immersed in a fluid? Whenever an object is immersed in a fluid, an upward force of upthrust acts on it. So you will write U or upthrust here. 1300 plus your answer equals to your upthrust. Your upthrust correct to two significant figures comes out to be 1400 Newton. Simple. The water has a density of this, you have to calculate the depth. Why? How will you do that? Now you remember, upthrust is equals to the density of the fluid gravitational field strength into the volume of the object. Upthrust की value क्या है? 1400. What is the density of the fluid? 990. What is the gravitational field strength? 9.81. What is the volume of the object that is immersed inside the water? What is the volume of the object that is immersed inside water? Can you realize this is a cylinder? What is the volume of cylinder ka formula? Pi r square h. Do you know the radius? No, but I know the diameter. 0.78. Can you calculate the radius? Yes, if the diameter is 0.78 meters, radius will be half of it. 0.78 divided by 2, that is equals to 0.39 meters. This equals to your radius. Your height is equals to y. Can you calculate the value of y? Yep. Pi into r, that is 0.39 square, into the height, that is y. 1400 divided by 990 into 9.81 into pi into 0.39 curve square is equals to your height or depth, that is y. What does your depth comes out to be? Handy. What does your depth comes out to be? Put it in the calculator. Your depth comes out to be 0.30 meters. Perfect. Let's further move ahead. The person can stand anywhere between A and B. Okay, so the person, this cute little person can stand anywhere between point A and point B. Okay. On figure 2.3, sketch the variation of the depth of the bottom of the cylinder with the distance of the person from A. For the distances between 0 to 6 meter, numerical values are not required. Okay. So बेटा you have to tell कि किस तरह आपकी depth vary कर रही है. How does this depth y varies as the distance of the person from end A varies. Basically, अगर सिंपल अल्फाजों में मैं पुट करूं तो आपकी डेप्थ वाई किस तरह वेरी कर रही है अगर ये पर्सन राइट पे जा रहा है या लेफ्ट पे जा रहा है. ओके, लेट्स सी, लेट्स एग्जामिन इट इन डिटेल. Let's say the person is at x is equals to 0. ठीक है, लेट्स से पर्सन कहाँ पे है एट अ डिस्टेंस ऑफ 0 at this point. If the person is at this point, his entire weight will act through the hinge. The clockwise moments due to the person will become 0. This entire category will become 0. However, there will still be some clockwise movements due to the uniform beam, that is of 1700 Newton. इसको बैलेंस आउट करने के लिए you would need an upward force from the cylinder. That upward force will only be provided if you are immersed into the water. So even at a depth of 0, even at a distance of 0 meters, you will have some depth inside the water. Why? Because there will be some clockwise movements due to the uniform beam. To balance those clockwise movements, you will need an upward force to create anti-clockwise movements. Hence. You need some amount of cylinder to be immersed in water. Now, as the person moves away, let's say the person is now at 6 meters. Oh. Let's say now the person is at 6 meters. Let's mark it here. Let's say now the person is at 6 meters here. Now his weight 660 Newton multiplied by 6 will create maximum clockwise movement. To counter this clockwise and this clockwise movement, you want a greater force in the upward direction. To counter both of these clockwise movements, you need a greater anti-clockwise movement, hence the force in the upward direction will be greater. If the force in the upward direction will be greater, the upthrust must be greater. If the upthrust is to be greater, the depth that is immersed inside the fluid must be greater. Y must be greater. So at the maximum distance, the depth will be greater. You will draw a line like this, increasing like this. Simple, nothing complicated. Here you will get 1 marks if you start from a positive y-intercept and 1 marks if you draw an upward sloping line. Let's further move ahead. A truck of mass 9400 kg moves with a constant acceleration in a straight line down a slope as illustrated in figure 3.1. Okay. At point A, the speed of the truck is this. अच्छा जी, point A पे speed of the truck क्या है? U, that is 13. Point B पे speed of truck क्या है? 22. Okay. The distance between the truck is 180. You have to calculate the acceleration. How will you do that? Very, very easy. Your initial speed is 13. Final speed is 22. Distance moved is 180 meters. You have to calculate what? You have to calculate acceleration. How will you do that? You will say v square is equals to u square plus 2as. Have we studied this formula in kinematics? Yes, we have studied this formula. V square is equals to u square plus 2as. Do you have the value of v? Yes, 22 curve square. Do you have the value of u? Yes, 13 curve square. Plus 2 into acceleration that we have to find out. Displacement is 180. 22 square minus 13 square divided by 2 into 180. Can you calculate the acceleration? Let's do that. 22 ka square minus 13 ka square. 2 into 180. Your acceleration comes out to be 0.875 ms minus 2. You can write your answers till two significant figures, three significant figures, both are acceptable. Calculate the gain in kinetic energy. Okay, how do you calculate the change in kinetic energy or gain in kinetic energy? 1 upon 2 into mass into final velocity का square minus initial velocity का square. What is your mass here? बच्चों यहाँ पे mass क्या था ट्रक का? 9400 kg. Okay, 9400 kg. What is the final velocity? फाइनल वेलोसिटी क्या है? 22 का स्क्वायर. इनिशियल वेलोसिटी क्या है? 13 का स्क्वायर. Calculate this answer. What does this come out to be? 0.5 into 9400 into 22 curve square minus 13 curve square. Your answer comes out to be 148,000 joules. You can write it in a standard form as well, 1.48 and 10 raised to the power of 6 joules. Simple. Obviously, you can give the answer till two significant figures, three significant figures, whatever you feel is good. A short time after passing point B, truck R moves in a straight line on horizontal ground. The driver of the truck applies the brake. Okay. Figure 3.2 shows the variation with time t of the momentum of the truck. Okay. So this is how the momentum of the truck is varying with time. Okay. This is for truck R. Okay, let's write it here. ये है truck R के लिए. Okay. Define force. What is force? Force is rate of change of momentum. Simple as that. Okay. You have to calculate the average resultant force. How do you calculate the average resultant force? Average resultant force you have to calculate between time t is equals to 0 and time t is equals to 15. If you want to calculate the average resultant force, you will take the change in momentum between time t is equals to 0 and time t is equals to 15 divided by change in time between time t is equals to 0 and 15. Okay. Let's zoom in a bit. What is the initial momentum at time t is equals to 0? This. How do you calculate this? Can you realize from 20 to 25 you are covering 5 units in how many boxes? 5 यूनिट्स कवर करो कितने बॉक्सेस में 10 बॉक्सेस में वन बॉक्स में कितने यूनिट्स कवर होंगे 0.5 this will become 21 21 is your initial momentum. Let's write it here. One second. This initial momentum is 21 into 10 is the power of 4. Am I right? Yeah. At 15 seconds, what's the final momentum? This comes out to be 2.5. Okay. Your final momentum is 2.5 into 10 is the power of 4. Can you calculate the change in momentum? Final momentum minus initial momentum divided by change in time. Change in time is 15 seconds. What is the final momentum? 2.5 into 10 is the power of 4. Initial momentum is 21 into 10 is the power of 4 divided by 15. What does your force comes out to be? Negative 1.2 into 10 is the power of 4 Newton. Easy peasy, lemon squeezy. One mark is very unfair. It should have been a two marker question. Okay, so there is another truck S. Okay, so there is an other identical truck S which has the same initial momentum as truck R. So what was the initial momentum? Can anyone tell me? Do you remember from the last question? The initial momentum was 21 into 10 is the power of 4. Okay. Truck R experiences a constant force equal to the force in B part 2. Okay. State and explain whether truck S will take more time, less time, or the same amount of time to come to rest as truck R. Okay. First of all, how much time is truck R taking? I think up till here that is 22.5 seconds. Okay, so truck R, you can write here, truck R comes to rest, comes to rest in 22.5 seconds. Now let's calculate it for truck S. Truck S has the same initial momentum that is 21 into 10 is the power of 4. Final momentum will be 0. Your average force is what? Negative 1.2 into 10 is the power of 4. I think this is it. Yeah. You have to calculate the time. How will you do that? Force is equal to change in momentum over change in time. What is the force? Negative 1.2 into 10 raised to the power of 4. What is the final momentum? 0. What is the initial momentum? 21 into 10 raised to the power of 4 divided by change in time. Can you calculate the time? Yes. Minus 21 into 10 raised to the power of 4 divided by 1.2 into 10 raised to the power of 4. Let's calculate it. This cancel out. Negative will also get cancelled out. 21 divided by 1.2. The answer comes out to be 17.5 seconds. So truck S comes to stop or comes to rest in 17.5 seconds. Hence, truck S takes less time than truck R. So you can write here. How will you write now? One second. Let me put the working on the downside. Let's do one thing. Let's put this working on the downside. You will say truck R comes to rest in 22.5 seconds. However, truck S comes to rest in 17.5 seconds. And you can obviously show the calculation as well. Lastly, you will say, hence, truck S takes less time compared to truck R to come to rest, compared to truck R to come to rest. Simple, easy peasy. Let's further move ahead. Okay, let's see this. A device containing a microwave emitter and a receiver is placed in front of a large metal sheet in a vacuum as shown in figure 4.1. Okay, so this is a microwave emitter and a receiver. This is a metal sheet. Okay. The line XY is perpendicular to the metal sheet. Okay. The device emits microwave of this frequency. Okay, so this is the frequency of microwave. Okay. When the device is at position P, a stationary wave is formed between the device and the sheet. Okay, when the device is at position P, a stationary wave is formed between the device and the metal sheet. Okay. Explain how the stationary wave, including the nodes and antinodes, is formed. We have to tell how a stationary wave using a node and antinode is formed. Okay. Now, first of all, what will you say? First of all, this is a four-marker question. What will you say? The microwaves emits incident progressive waves. The microwave emitter, you can say, emitter emits incident progressive waves. Okay. Next point. These waves hit the metal sheet. These waves hit the metal sheet and get reflected and get reflected. This gives rise to this gives rise to reflected progressive waves. Reflected progressive waves कब आ गई बेटा? When they hit the metal plate and get reflected. These are your reflected progressive waves. Simple, the dotted one. Third point, you will say the superposition of incident progressive waves. See, the examiner has given you so much space to write about how waves are formed. The superposition of incident and reflected progressive waves gives rise to gives rise to stationary waves. Simple. Nothing complicated here. अच्छा जी. उसके बाद you also have to tell about nodes and antinodes. What are antinodes? Antinodes have the maximum amplitude. Antinodes are points with maximum amplitude. With maximum amplitude. What are nodes? What are nodes, बच्चों? Nodes are points with minimum amplitude. Simple, easy peasy, lemon squeezy. Calculate the wavelength of the microwaves. Now we have to calculate the wavelength of the microwave. V is equal to F lambda. All microwaves travel with the speed of light, that is 3 into 10 raised to the power of 8 ms minus 1. 3 into 10 raised to the power of 8 ms minus 1. What is the frequency? 6.3 gigahertz. Now, what do you mean by giga? Giga is equal into 10 raised to the power of 9. Wavelength comes out to be here. Wavelength is equal to 3 into 10 raised to the power of 8 divided by 6.3 into 10 raised to the power of 9. What does your wavelength comes out to be? Wavelength comes out to be 0.048 meters. Perfect. At point P, the receiver detects a maximum amplitude of the stationary wave. Actually, point P pe you have a maximum amplitude of the stationary wave. Let's erase everything. Point P pe you have an antinode. Okay, represented with A. The devices move slowly from point P along the line XY, and the receiver detects a series of minimum and maximum amplitude. The first time a minimum amplitude is detected by the receiver is at point Q. Okay. यहाँ पे आपका minimum amplitude आ रहा है, that is node. Okay. You have to calculate the distance peak. Do you remember that from node to antinode, what is the distance? 1 over 4 lambda. What is your lambda value equal to? 0.048. So 1 over 4 into 0.048. This comes out to be 0.012 meters. Simple. The intensity of the microwave emitted by the device is increased. The frequency of the microwave remains unchanged. The devices move slowly from the line XY from point X until the next maximum amplitude is detected at point R. Okay. State and explain whether the distance QR is greater than, less than, or the same as PQ. Okay, देखो हो क्या रहा है? The intensity of the microphone is increased. Okay, the device is then moved slowly along the line XY from point Q until the next maximum is achieved at point R. Okay, so let's say this is point R. I'm assuming a point R. Okay, at this point you have an antinode maximum amplitude. You have to tell whether this distance, that is equals to 1 over 4 lambda, has changed or not. If you are increasing the intensity, बेटा अगर आप intensity increase कर रहे हो, that does not affect the wavelength, hence the distance QR will remain unchanged or same. You will say intensity, or you can say wavelength does not depend on intensity. Wavelength does not doesn't depend on intensity. Easy. Since wavelength remains unchanged, what will happen since wavelength remains unchanged? What will happen? Distance QR remains unchanged. Perfect. Let's further move ahead. A stationary loudspeaker emits sound of constant frequency. A microphone is placed near to the loudspeaker and connected to a cathode ray oscilloscope CRO. The trace on the screen of the CRO is shown in figure 5. This is the trace on the CRO. The time-based setting of the CRO is set to this. Okay, that means 1 centimeter on the x-axis represents this. और x axis पे 1 सेंटीमीटर कितने बॉक्सेस है? 1 2 3 4 5. 5 boxes is equals to 1 centimeter, and 1 centimeter represents the time of this. The speed of the sound emitted by the loudspeaker is this. Okay, this is the speed. Calculate the wavelength of the sound. You have to calculate the wavelength of the sound. How will you do that? Very, very easy. Let's zoom in a bit. First of all, can you realize this is the starting point of the wave? This is the ending point of the wave. How many boxes have we covered? 5, 5, 5, 5, 5, and 4. So 5, 5, 20, 25, and 29. So just hold your horses. If 5 boxes equal to 1 centimeter, if 5 boxes equal to 1 centimeter, 29 boxes will be equal to how many centimeters? X. Let's calculate this. 29 divided by 5. This comes out to be 5.8. X comes out to be 5.8 centimeters. Now, 1 centimeter on the x axis represents 5 into 10 raised to the power of negative 4. 5.8 centimeter कितना time represent करेंगे? What will the time period be? 5.8 into 5 into 10 raised to the power of minus 4. What does your time period comes out to be? 5.8 into 5 into 10 raised to the power of minus 4. The time period comes out to be 2.9 10 raised to the power of minus 3 seconds. You have to calculate the wavelength. How will you do that? Very easy. V is equals to F lambda. Velocity is 330. Frequency को किस तरह put करेंगे? 1 over time period 2.9 into 10 raised to the power of minus 3 into lambda. Can you calculate the wavelength? Yep, 330. Wavelength comes out to be 0.957 meters according to three significant figures. Easy peasy lemon squeezy. आगे बढ़ते हैं. The loudspeaker now moves in a straight line while emitting the same sound of constant frequency. The period of the trace on the CRO increases continuously. मतलब time period आपका increase कर रहा है continuously. If your time period is increasing, you know frequency is equal to 1 over time period. If time period is increasing, frequency will decrease. If your frequency is decreasing, that means your wavelength is increasing. That means the loudspeaker is moving away from you at an increasing speed. You will say the loudspeaker is moving away at an increasing speed. Simple. Let's further move ahead. आगे बढ़ते हैं. A cylindrical copper wire P of length this is shown in figure 6.1. ठीक है, एक cylindrical copper wire है जिसकी length ये है. The current in the wire is this, the resistance of the wire is this, the total number of charges. This is the total number of charges, okay. The resistivity of the copper wire is this. You have to calculate the potential difference P is equals to IR. Current क्या है? 0.85. Resistance क्या है? 3.3 milliampere. Can you calculate the potential difference? Just multiply it. The potential difference comes out to be 2.8 into 10 raised to the power of minus 3 volts. Now you have to calculate the cross-section area. You know that the resistance is equal to resistivity into length divided by area. How will you calculate the cross-section area? Cross-section area is equal to resistivity into length divided by resistance. What is the resistivity? 1.8 into 10 raised to the power of minus 8. What is the length? What is the length of the wire? 0.24. What is the resistance, बच्चों? 3.3 milliohms minus 3. What does your area come out to be? 1.3 into 10 raised to the power of minus 6. Show that the number density of charge carriers in the wire is this. You have to calculate a small n. That is the number density of charge carriers. What is a small n actually? Number density of charge carriers क्या होता था? Number of electrons per unit volume. What are the total number of electrons? 2.6 into 10 raised to the power of 22. 2.6 into 10 raised to the power of 22. How will you calculate the volume here? Can you realize this is a cylinder? Cylinder का volume क्या होता है? Pi r square h. Okay. So pi r square h. Luckily, you are already provided with the cross-sectional area. You don't need to do this pi r square h. You can just substitute area in place of it. Do you have the height? Yes, 0.24. Okay. So 2.6 into 10 is the power of 22 divided by your area, that is 1.3 into 10 is the power of minus 6 into the height, which is 0.24. What does your answer comes out to be? 8.3 into 10 is the power of 28. Calculate the average drift speed of the charge carriers. Drift velocity or drift speed is equal to current divided by NAQ. Current क्या था? Yes, genius is 0.85 ampere. Okay. What is the number density of charge carriers? 8.3 into 10 raised to the power of 28. What is the area? 1.3 into 10 raised to the power of minus 6. What is Q? Q is the charge on an electron. This is equals to 1.6 10 raised to the power of minus 19. What does your average drift velocity comes out to be? Drift velocity क्या आती है? 4.9 into 10 raised to the power of minus 5 meters per second. Simple. A different copper wire Q has the same volume as wire P but non-uniform radius as shown in figure 6.2. अच्छा जी non-uniform radius है but volume क्या है? Same है. Okay, no problem. The radius R1 at the end X of wire Q is the same as the radius of wire P. Okay, यहाँ पे जो R1 है, this is the same as the radius of wire P. Okay, the radius 2 is smaller than R1. Okay. State and explain how the resistance of wire Q compares with the resistance of wire P. Okay, very easy. Now, one thing is very evident. One thing is very evident. Can you realize if R1 is equals to RP, this cross sectional area will be the same as the area of P. But as you go forward in the wire, your area decreases. This area is much less than the area of wire P. Hence, you can conclude, you can say here, यहाँ पे आप कह सकते हो कि average cross sectional area, because if I add up both the faces, if I calculate the average cross sectional area of wire Q is smaller compared to wire P, smaller compared to wire P. Okay, we have studied resistance is inversely proportional to area. If your area is less, resistance of wire Q will be greater. Hence, resistance of wire Q will be greater as area is inversely proportional to resistance. As area is inversely proportional to resistance. Easy peasy lemon squeezy. Now, one last thing. If you realize this is a four marker question, this is a four marker question. Yeah, here we have it. And you have only obtained 2 marks up to now. Can you realize the volume is remaining same? Volume is equals to area into length. If your area is decreasing, if the cross-sectional area of Q is less, the length of Q will be greater. This should be your third point. To keep the volume same, length of Q will be greater. Length of Q will be greater. And resistance is directly proportional to length. Directly proportional to length. Hence, the resistance of Q is greater than the resistance of P. Easy peasy. Now you have a score 4. Let's further move ahead. Okay, on figure 6.3, sketch a graph of the variation of the average drift speed of the charge carriers with the distance from end X of wire Q. Drift speed is equals to current over NAQ. Can you realize drift speed and area are inversely proportional? As you are moving further away from X, जितना आप x से दूर जा रहे हो आपका एरिया कम होता जा रहा है your velocity will increase. You will have a graph somewhat like this. Also, why I have taken a positive y-intercept? Because even when the distance from x is zero, बेटा जब आपका distance from x zero है, जब आप इस phase पे भी हो, तब भी आपके कुछ ना कुछ drift velocity है. That's why I have taken a positive y-intercept. Simple. Smooth phase and move ahead. An isolated stationary nucleus Q. Okay, stationary word is very important here. Decays into nucleus R in an alpha particle. The alpha particle has a speed of this. Okay. Complete the decay equation. Okay. When an alpha particle decays, your mass number decreases by 4. So this will become 2 to 6. And your proton number decreases by 2. This will become 86. By considering momentum, calculate the speed of nucleus R after decay. So the total momentum before decay will be equal to the total momentum after decay. Since nucleus Q was stationary, the total momentum before decay will be zero. After decay, the alpha particle that has a mass of 4 multiplied by the atomic mass unit U is traveling with a speed of 1.5 into 10 raised to the power of 7. The particle R will travel in the opposite direction to give an overall momentum of 0 multiplied with the atomic mass unit multiplied with velocity. Let's take it to the other side. 2 U. Velocity is equal to 4U 1.5 into 10 raised to the power of 7. Can you calculate the answer of velocity? Yes. You cancel out. 4 over 2 into 1.5 into 10 raised to the power of 7. What does the velocity of V or the velocity of R comes out to be? 2.7 into 10 raised to the power of 5. Which three quantities remain conserved during the decay? Energy, proton number, and nucleon number. Simple.